Welcome all of you. Today we will be discussing about computer networks. So it would be an interesting topic for all of you. Many times we use this word computer network, and anytime we listen this word, internet access comes in our mind. Using internet, we are getting a lot of information today, and internet is nothing but a result of the network technology. Today we will see how this network technology enabled us to access internet, what happens when we access internet, and at the same time, network doesn't mean only internet. Network is a very wide term which is being used in computers. So as a part of your basic electronics curriculum, networking is kept as a topic to introduce all the networking terms to you. Later on, for computers, electronics, IC, and these high-tech branches, they will be having computer networks as a subject itself. So there we will be understanding this these networking concepts in very much detail. Today we will be introducing all those terms which are used in networking. So there, let us see the basic usage of computer network. Computer networks are used for business applications, home applications, mobile users, and social issues. Business applications means everything whichever is related with the business. So for offices, network is required. In domestic applications, network is required. Network is required for the mobile access, and networks would be too much helpful in social issues. Now let me show you this slide first. So this is showing you a business application. Okay, in this case you are seeing a client computer, right? Along with that, a second client computer is there, which are being used by two users, and these two client computers are connected to a network. So this network is allowing these two clients to communicate with each other. At the same time, this network will allow these two clients to access the resources of this server. Okay, consider a case wherein this is not there. Consider a case wherein these are not there, these links are not there. That will make this client, and this server as a standalone PC. They will be standalone computers. So now, if these are connected with each other, they are creating a network. But if they are not connected with each other, they are standalone computers. Okay, now immediately you can come to know what a network is, right? Network is a kind of entity which is bringing all the computing devices together with some mean. Now there are multiple means of connecting these devices all together. We will be exploring those different things. Now let us go 2 slides before, that was elaborating use of computer communications. where at all we use the networks. Where at all we use the networks. So here all the applications are listed: blogs, chat rooms, email accesses, fax. Yeah, you can send and receive fax using the communication means. Then fax is a direct example. Let me change the pointer first. Okay, fax is an example of telecommunication application. Then file transfer protocol, FTP, instant messaging. Instant messaging means you send an SMS or you message using WhatsApp, right? If you use Skype, right? These are the examples of instant messaging applications. Then internet as a whole, FTP, instant messaging, chats, blogs, these all are the internet-based applications. But here internet means if you are surfing the net, you are making use of that. The news groups. Over internet you can have news groups. Then RSS feeds, right? RSS means really simple syndication. So this is the way by which you can receive all the content of your interest, right, by using only a single RSS client. Then video conferencing, then VoIP. VoIP is nothing but using telephones, using the telecommunication over IP. IP means internet protocol. So if you use Skype, if you make a voice call using WhatsApp, or if you are using FaceTime, or you are using Facebook for making voice calls, then it is said that you are using VoIP communication. And at the same time, an entire exchange of VoIP is possible. Then the World Wide Web access, Web 2.0, web folders, wikis, these are the different applications of web. So these are nothing but the applications of network. But these are not the all, right? Here we have tried to list few applications among them. Networks. Let us define a network the way most of the classes would require defining those terms. So a network is nothing but a collection of computers as well as devices connected together via communication devices and transmission media. So what they do, they as a whole form a network, right? Now the advantages of the network include they facilitate communication, they allow you sharing the hardware, they are used for sharing data and information. Using network you can share the software, and using network you can do financial transactions as well. We can term here e-commerce, right? So these are different applications of networks. This we have already discussed. The similar kind of application is being shown here again in a different configuration. Here it shows you a client-server model that involves requests and replies. Client and server model that involves request and replies. So you can see here in previous case we are having a client machine. It is connected with a server. How this client is talking with the server, that is being shown here. Okay, any of the communication will be based on this model. So here client machine and server machine, they are running the processes at both of their end. So the encircling circle inside the block is showing you the client process, and here this is showing you the server process. Okay, if this process is running on the server side, it says that client can contact anytime, and if this process is not running, then it can be said that server machine is off. So if server process is on, let me make this pointer always available, visible. Okay, so when this client process is sending a request to the server process, the server process will send a reply message to the client process, and this way this loop will be completed. Okay, any of the times if client wants to have server access, the request and replies will be going in this fashion. Okay, so server process is a process which will be continuously on, and any time client can request the resources from the server process. So this is the way the client and server process goes on. Say for example, client and server processes, we can have a very good example of it when we access our mail accounts. So when you access a mail account, you will be typing mail.xyz.com. Once you will type mail.xyz.com in your browser, automatically a login page will be opened, and to this login page you will be entering your credentials, your username and password, and then a window showing your messages will be opened on. Okay, why? Okay, why? Can you tell me why the user authentication page opens in your browser? When you are typing mail.xyz.com and send enter, right, from your browser, why the user authentication page comes in your browser? Okay, let me tell you. That is because of the server process running at the mail server side. So once you send a request, right, of connection using your browser by typing mail.xyz.com, the XYZ mail server will be sending you the authentication page. So that is nothing but a reply which a connection request was sent by the client. And see, if the server process at the mail server side is not running, then in that case if you send mail.xyz.com, then nothing will appear, right, in your browser. Instead an error message would be displayed. So this lets you know about the client machine, server machine, client process and server processes, and the way the business applications or any network application would be having communication. In this figure we are having a peer-to-peer system of network. In a peer-to-peer system there will be no fixed clients and server defined. So what we are seeing here, multiple computers are there, but we will not be identifying them as a client PC, right? But rather we will call them peers, right? So multiple peer computers are there, and they all are communicating with each other. Now it is presumed that these all are network connected. That is why they all are being able to talk with each other. But the major difference between the previous slide and this slide is that none of the machines are acting as server and client. If it is like that, then in that case the server's permission is required, right, for any of the communications. If client A wants to talk to client B, then a mediator server would be there in between in client server model. And in case of peer-to-peer model, the way we have seen in this figure, every PC, right, every person, every entity will be free to talk with any of the entities there. So that gives a very good example of peer-to-peer communication. Okay, now this shows you some forms of e-commerce. Let us classify e-commerce transactions. You can say there B2B, that is business to consumer. B2B, that is nothing but business to business. G to C, there is government to consumer. C to C is consumer to consumer, and P to P is peer to peer. So these are not technical classifications, but these are the different classifications which has got evolved based on the network usage and kind of network applications are deployed. So if you go there and try to classify those network accesses and network application deployment, then you'll be able to classify all those different things happening, right, in 5 different classes: B to B, right, B to C, G to C, C to C, and P to P. So business to consumer, business to business, government to consumer, consumer to consumer, and peer to peer. Okay, let us have an example. Business to consumer. If you are ordering something online, if you are purchasing a mobile phone or if you are ordering a book online, then in that case you are directly contacting some of the business houses, right? And those business houses will be running their online e-portal, online e-stores running, right, constantly throughout the time, day and night, all the time. And you can purchase something by going online. So this is a very good example of B to C, right? Then business to business communication. A car manufacturer ordering, here we are talking about the car manufacturer ordering tires from a tire manufacturer. So none of them are consumers, they both are business houses. This is business house, this is business house, and this tire manufacturer is also a business house. So this is an example of B to B. And third is government to consumer. So if you pay tax, if you pay income tax online, then it is nothing but an G to C application. Consumer to consumer, if you sell something on auctioning sites, right, something on classified sites, they are auctioning second-hand products online. So that is nothing but an example of consumer to consumer application. And third is peer to peer. Peer to peer example, if you download something, right, from P2P network, if you download something from P2P using P2P clients, then that is called a P2P application. Generally, most of the time when students download videos and audios on P2P networks, they are nothing but this P2P. This is showing you combinations of wireless networks and mobile computing. Okay, mobile users, how mobile users make use of network. So let us consider 4 different types. Desktop computers in offices, a notebook computer used in a hotel room, networks in unwired building, store or inventory with an handheld computer. So here, desktop computers in an office is not an example of a wireless network access, neither mobile network access. Okay, so because all the desktops in your house or your office would be connected with wires, so it is not an example of wireless network, neither it an example of mobile computing, because nothing moving part is getting involved into it. A notebook computer used in a hotel room, yeah, this is an example of mobile computing, and it's not an example of wireless. If the user is using the telecom services, in that case it is this example, this way it is true. Networks in unwired building. Okay, if your office is not having wiring done, right, for all the nodes, then in that case it's an example of wireless network access. Store inventory with a handheld computer. Okay, if you are having a store, very large store with so many things spread it throughout different places in the store, and you are using a handheld handheld device for the keeping the inventory of it, So it's a very good example of wireless computing as well as mobile computing. Social issues. How social issues are affecting networking? Few things are being listed here: net neutrality, Digital Millennium Copyright Act, profiling users, and phishing. These are the major social issues. They are affecting the network usage. Net neutrality, this is a term which has got evolved right now. It says that all the network accesses should be fair. Right, none of the network services should be given higher priority as compared to others. All the network services would be having neutral accesses, and that is especially required in case of better access and better distribution of information, right, without any kind of bias. Digital Millennium Copyright Act, using networks, piracies should be prevented. And for this, for preventing piracies, a lot more enforcement in terms of networking, in terms of networking services would be required. Then profiling users. Every user would be having some kind of network access pattern, and based on that network access pattern, companies would be profiling the users, and based on that the users might be contacted based on those profiling. And in fact this should not be done, right? And phishing, most of you might be knowing about this. Phishing is displaying something which you are not, right? So sometimes online spammers, right, online hackers, they misuse internet by using this phishing kind of contents. Now let us talk about network hardware. Network hardware, they are classified into 4 different categories: personal area network, local area network, metropolitan area network, wide area networks, and the internet. Here it shows you the classification. Personal area network is the interprocessor distance. Interprocessor distance here tells you how far the devices are placed. If the devices which are networked, they are placed within 1 meter distance, they are called personal area network. Their short term is PAN. If you are using your mobile phone and that mobile phone is connected with a Bluetooth headset, or it's with a Bluetooth speaker, your laptop is connected with a Bluetooth keyboard, or desktop is connected with a Bluetooth keyboard, then these all are examples of network, and they are creating a personal area network wherein all the devices are connected in very much nearby network, and the distance of all these devices would be roughly said 1 meter distance. You can have up to 10 meter distance, but they are said personal area network. Then in case of local area network, LAN, anything whichever is there in 10 meter, 100 meter or 1 kilometer distance within a room, within a building or within a campus, then all of them are said to be on a local area network. So if your devices in your office, they are connected with each other by wired or wireless mean, they are said to be on network. If you are having multiple computers related to your home, your mobile phones, computers, they are connected together inside your home, that is said to be a local area network. And in your college, if all the departments are connected with each other, they are also forming a local area network. Further, that college-wide area network is also given a separate term. Is sometimes it is a reference with a term called campus wide area network, right? Then MEN comes into picture, metropolitan area network. If your network is city wide, then it is said to be metropolitan area network. Then wide area network and internet. A country, if a network is spanning up to the country or in continent, they are said to be wide area network. And if a network is there covering the entire globe, right, the entire planet, entire earth, it is called internet. So the widest network, right, among all these examples is nothing but the internet, and that internet is spanning across the planet earth. So this was the classification of interconnected processors by skill. This is showing you a personal area network. This is an example of local area network. Laptops are connected with an access point, and Ethernet switch is connected with this computers. So they are forming a wired area network. So here two LANs are shown there. One is called a wireless LAN and second one is called wired LAN. Okay, in terms of technical terminology, this wireless LAN is called as 802.11 Ethernet, and this is called switched Ethernet. This is called 802.3 Ethernet. Okay, as we had seen in the first in the previous figure, connecting different processors with different vicinity, there we had a reference metropolitan area network, and metropolitan area network is the network which spans across the city. So here this is nothing but that metropolitan area network. This is spanning across entire city. So you can see there all the houses are connected with a head end and internet. Head end is okay, basically this is a metropolitan area network based on a cable TV. So in all of us case, if you want to have a better example of metropolitan area network, then cable networks, they are a very good example of metropolitan area network. All of us would be having some kind of cable TV service at our home, and in that cable TV service, the cable TV service provider would be extending the connection up to our home. In extension of that connection till our home, the kind of schematic being displayed here would be used. So here the head end would be the office of the cable TV service provider, and they will be reaching to all the consumers using the different level points, say junction points, and at these junction points they might have placed the amplifiers. Okay, so this is a very good example of a metropolitan area network. Okay, this is an example of network because everything, resource sharing is being done here. A single resource is being distributed among multiple users in this case. Then wide area network. As we had seen that if a network is spanning across the country or the continent, this is a better example because here we are seeing that a wide area network that connects 3 branch offices in Australia. So it is a country and continent both. So you can see there a router placed in Perth is connected with Brisbane and Melbourne. So these 3 are the different cities in Australia. They all are connected together and they are creating a subnet. They are connected with each other using transmission lines. Okay, so if you are having a network like this, it is said wide area network. And this would be possible in the multinational company offices, in government offices, right? This kind of connectivity is possible using the telecom service providers. So basically these lines would be provided by telecom service providers. This is showing you wide area network again, wide area network using virtual private network. Okay, in previous case what we are seeing that all of these are connected with each other and they are creating a subnet. But here that subnet is considered as internet here. Okay, anytime we say that we are on internet, it automatically confines that all those devices which are connected to internet are accessible. So in this case, when we are using the transmission lines, individual transmission lines, so it tells that dedicated connectivity are there between this router and this router. But in the other figure, when we are seeing this, so in this case dedicated connectivity is not there between these two routers. Instead these two routers are connected via internet. Okay, it means that the line between these two are not dedicated for them only. So any other persons connected on that line may as well would be using those lines. Okay, but this is a case of when using VPN, virtual private network. So here the subnet is formed using the connectivity which is used for getting connected to internet. So we can say that all of these three terminals are connected with each other via internet. So the subnet is being connected by internet, and still it is possible to have a private connection between all of these three as if they were having the dedicated connectivity like in this case. So in this case no one else will be able to use this line. They are dedicated with these two entities only. But in this case these lines are over internet, they are shared lines. But still being on shared line, if you can create a kind of network which will look like that these three devices are connected with each other all the time, that is called VPN, virtual private network. So this is showing you an example of VPN over WAN. Okay, this is a third illustration of wide area network. Okay, in this wide area network you can see a WAN link is there that is using an ISP network. So here an ISP network is there, again a transmission line is used as it was used in the case before. But what difference is there here? What difference we are getting here is, even though ISP network is there, the lines are not on internet. So a spare capacity of the ISP network is being provided to the different offices. So you can say it's a WAN link with distant entities connected with ISP network. Now the network softwares. What all we have seen, that was discussing about different network services, network applications, and network deployment. Now let us take something on network software side. As we have seen that a network can get established by connecting two different devices. Okay, now that is not all. If you connect two different devices with each other via hardware, then a software counterpart for this connectivity remains unanswered. Okay, those two devices should be network aware. They should have network stack running on both of these two devices. So network stack running means we are referencing the network softwares which are running on those two devices. Without those network software entity, it is not possible to have network established between those two devices. So how this network software entity would be functioning inside the network? Let us see that. Okay, here it shows you the protocol hierarchy. So in that case, you can see two different hosts, host 1 and host 2. They are connected with each other. Host 1 is connected with host 2. So there host 1 is having this entire thing with it. Okay, this is host 1 entirely, and this is host 2. Okay, so in this case, host 1 is having multiple entities inside it. These are nothing but the soft entities which are partitioned inside one host, and it is required especially for network softwares. Okay, you can see that 5 layers are there: layer 1, layer 2, layer 3, layer 4 and layer 5 inside host 1. And similar number of layers are there in host 2 as well. Okay, let us presume 5 different entities here. Later on we will be increasing this number. Let us consider 5 right now. Okay, so these two entities are connected using physical medium. Now you can see that all of these layers are talking with each other. They are talking with each other, right? You will have to see my pointer. Please be with me along with the pointer where this pointer is moving. So there similar kind of discussion between the individual layers is there, right, at the host 2 as well. Simultaneously you are seeing there within the host every layer is being able to talk with its immediate layer. Okay, layer 5 is not talking with layer 3 in any of the case. See that. Okay, so every layer is being able to talk with its immediate layer, right, preceding or proceeding, right? Okay, so there it is there. Simultaneously you can see that dotted lines are there which are running across the layers. So you can say that layer 1 is talking with the layer 1 of the end device, the other end device. That is said layer 1 protocol. Then layer 2 device is again talking with layer 2. So this is said layer 2 protocol, layer 3 protocol, layer 4 protocol and layer 5 protocol. Okay. So the way layer 5 is talking with layer 5, it is using layer 5 protocol. Okay, layer 5 here is talking with its own host layer 4. They are using layer 4/5 interface. Fine. So this way this communication will be going on, and as an example, if host 1 is making communication with host 2, every packet being generated by host 1 would be traveling in this fashion: layer 5, layer 4, 3, 2, 1, and then it would be passed to the medium. Then again layer 1, layer 2, layer 3, layer 4, and it will reach to layer 5, the host 2. Okay, simultaneously when layer 5 is sending a packet to layer 4, ultimately it would be sending a packet to layer 5 of the host 2. but it would be sending that packet to the same host layer 4. Okay, let us proceed by one slide. Okay, here this shows you the same kind of example, right, in a different way. Let me see if I can zoom this. It's not possible to zoom it. Okay, so here protocol hierarchies are shown. Okay, same all this 5-layer case is being explained here is example using this 3-layer device. Okay, in this case location A and location B are there, considered as a host A and host B. Okay, this is a case, an example of a philosopher, translator and secretary architecture. So you can say there two different philosophers are there. One is a philosopher from India and another is a philosopher from Nepal, right? This is a philosopher from India. This is a let us say this is a philosopher from Germany, right? Not Nepal, Germany, because Nepal uses Hindi, majorly Hindi as a language. So there we are taking a German language person and a Indian language person. So location A is a Indian philosopher who is willing to have communication with German philosopher. So this is German philosopher. Okay, now see how the communication would be happening. Okay, when there is a message, right, when some kind of thought needs to get shared by the Indian philosopher with the German philosopher. Say for example, what kind of reaction a person would be having when he is asked a question, when he is in anxiety, this kind of thing, right? This message is to be passed to the German philosopher and identify what their responses are. So the Indian philosopher will be writing a letter, right? And this letter ultimately he will he will write in his own language, in Hindi itself, right? So he will call his secretary. He will call his secretary, right, for writing that letter. Okay, the secretary will come to this person and secretary will start writing the letter. When the Indian philosopher is dictating that letter, he will be dictating as if he is talking with the German philosopher. But the letter, when he is dictating, that dictation will be as if the Indian philosopher is talking with the German philosopher, right? Ultimately they will be having discussion with the secretary, but the letter would be written in a form as if the Indian philosopher is talking with the German philosopher. So this is said that between these two philosophers, the protocol of those two persons are being followed, right? So they would be behaving as if they are talking with each other, but ultimately they would be talking with their own secretaries. So these are layer to layer communication is happening here, but those communications are happening based on following the protocols at this top layer. In the same way, when the secretary will be writing a letter, the secretary would be knowing how to cover that letter, right? What should be the drafting of those letter, and that letter would be written in a form, in a way the secretary is referring to the other secretary. So this secretary would be communicating with each other following their own protocol, their secretary's protocol. These two would be talking with each other using their own protocol, but when they are having actual transactions, they would be having transaction here. Okay, now when the secretary would have written the letter, he will not be personally going to this fellow, right, for giving this letter to him. He will pass that letter, right, to the desk person in that office, in the Indian philosopher's office. and that office person will post it, right? Or we'll use some sort of means to send that message. Okay, when this secretary, when this office staff is sending those content, they would be knowing, they will be following the protocol at the office level. They will be writing the address, they will be marking the persons whom that letter is addressed, but ultimately they will not be feeling that they are talking with the philosopher. This office staff would be considering that they are talking with the other end office staff, and they will write the letter in that fashion. So this way, this communication will be taking place. Every layer would be discussing with each other the way they are discussing at that level, that layer, but ultimately the communication would be happening vertically. But they will understand that they are talking with each other horizontally, right? So this was a very good example of network communication. And inside network, this similar kind of happenings would be there in this protocol hierarchy. We will see how these sessions are handled later on. So you can say protocol 5 layer is generating a message, philosopher is generating a message, then it is being written in form of letter. So layer 4 protocol is there, the secretary is writing in form of letter. So layer 4 would be putting its own header on the message. Then it will be passed, the message would be passed to layer 3. Now layer 3 would be receiving that packet in multiple packets, right? It can be, the message can be separated into different messages, into short messages. So there, this M is converted into M1 and M2, and here this information is again assigned layer 3 headers. Okay, now this further will be passed to layer 2, and layer 2 will put headers as well as tailors, right? So header and tailor both would be there at layer 2 protocol. And you can see here similarly headers and trailers are being kept, and then again here again you are seeing that headers and trailers are there. So this way these things would be passed. Okay, these are talking about connection oriented and connectionless. We are skipping this slide, and here it is representing the layer relationships. As we have said that layer 4 would be able to talk with layer 4, layer 3 and layer 5 of that same device. In the same way, layer 2 can talk with layer 4 and layer 3. So here layer K can talk with K plus 1 or K minus 1, and the same layer would be horizontally, it would be considering in a way it is talking with the distant entity same layer protocol. So here it's showing you relations between services and protocol. So layer 3 is following layer 3 protocol, and it is using the services from layer 4, and it is providing the services to layer 2. Okay, this is showing you an OSI reference model. This is a very very good model for explaining networking understanding, networking functions. Okay, the way we had referenced 5 different layers, in this OSI reference model 7 different layers are considered. For learning purpose, this reference model is very good for understanding purpose, and in technically at present we are using 5 layer model itself, right, for all the communications which are happening in our day-to-day life. But it doesn't mean that it does not have all those 7 layers, right? But certain layers are merged among some layers in 5 layer model. So let us see how many layers are there in OSI reference model with 7 different layers. So here layer 7 is an application layer, layer 6 is presentation layer, layer 5 is session, layer 4 is transport, layer 3 is network, layer 2 is data link, and layer 1 is physical. At both the entities, these 7 layers would be there, application layer is giving you accesses to the network facilities. When you browse using your browser, when you type www.google.com, this is the browser, and that is nothing but the application layer. Now that application layer, when it receives the data from Google, it will be representing in some format, and it will be presenting you a graphical image would be represented in a graphical way, and audio content would be replayed in an audio content way. Different fonts of different language would be represented in its own content. This is a task of presentation layer. Below the presentation layer, you are finding session layer. So this session layer is keeping track of multiple sessions. Sessions as a whole, we can say, for understanding purpose. Say for example, you have logged into your Google Mail, and simultaneously in another window, a browser, another tab of the browser, you have opened Google as a search engine, right? So simultaneously two different sessions are running at your place. So you have only one internet connection. Over one internet connection, multiple sessions are active. So this task is being handled by session layer. Okay, once these sessions, individual sessions are there, say for example you are fetching your messages. So those messages would be sent, those messages, those emails would be packetized, right? And then that would be sent to the network layer. This packetization is being done by transport layer. Then it is sent to the network layer. So these packets, okay, you can see there from network layer you are finding this subnet. Okay, these subnets are intermediate devices which are there over the network. So those subnets would be having the scale up to network layer. Further layers would not be there at that place. So at this network layer, right, at this network layer, this entire span, the packets would be sent to different entities, right, based on the network addresses. So addressing and packet exchanges would be done at network layer, and that thing would be done using data link layer and physical layer. Physical layer is the wires which are getting connected with each other, and data link layer is giving you data integrity. None of the bits are being lost, or none of the noise or network anomalies are ultimately resulting in loss of data. So that is being guaranteed by the data link layer. So as a whole, on the other side, you can see application protocol data unit, presentation protocol data unit, session protocol data unit, transport protocol data unit, packets, frames and bits, right, would be there, the smallest, tiniest unit of these protocols. Now the way you can see, when a Google browser, when you are typing from browser and you are accessing Google, they are application layer. So application layer protocol would be following application layer protocol. Presentation layer would be following their own protocol. Session layer would be following their own protocol. See, this way the communication would be going on the way we discussed before. So right, with this we would be concluding this session today here. In fact, this networking is a very wide term which requires enormous amount of time and resources for understanding purpose, and networking still is a kind of subject where we would like to go on talking, right? But we will have to be with time, and today time is not allowing us to go any further than this. Sometimes again, if we get together, we will talk about networks, but for this course we are terminating our discussion at this point. Thank you. Thanks for listening me today. Wish you have a nice time.